Hi there. We're still working on Algebra 1 word problems, linear functions, and tonight I'm going to talk to you about a particular type of word problem. It's very, very similar to the other problems that we've been working on in this lesson so far, but it kind of gets a different reputation. It's called a mixture problem, and let me explain to you what it looks like. If you're following along in your Foerster book, this is problem number 18. It's the gasoline octane problem, and I'll read it first so that everybody can come to terms with what kind of thing we're talking about. It says the octane number of gasoline can be thought of as the percent of the compound octane in the gasoline. For example, 89 octane gas would be 89% octane and 11% something else. The only thing that's important is that 89 octane is 89% octane. Suppose that a wholesaler has 84 octane gas and 91 octane gas. The wholesaler mixes X gallons of 84 octane gas and Y gallons of 91 octane gas, and we're supposed to come up with an expression for the number of gallons of octane in the mixture. Okay, so here I have summarized sort of the problem. First of all, it's problem number 18 if you have your book along. It's a mixture problem, and we know our wholesaler has an 84 octane gas, a 91 octane gas, and is going to make a mixture of these. The problem tells us that it's going to have X gallons of 84 octane gas. So I'm going to put X right here to tell me the number of gallons that he has of the 84 octane. And it also tells us that the wholesaler has 91 octane gas, and we're going to say that that's Y gallons of that. Okay? So the first thing again is to write an expression for the number of gallons of octane in the mixture. Well, we know if we have 1 gallon of gasoline, or 1 gallon of this 84 octane mixture, it's 0.84 gallons of octane, right? Because it's 84% of it is octane. So again, just like in the other problems that we talked about, the 84 ends up being the rate of the octane, and X is the number of gallons. So if we wanted to figure out just the number of gallons of just the octane, we would take 0.84X, and that would be the number of gallons of octane in X gallons of all the gas. Remember, it's 84% octane. Likewise, if we wanted to find the number of gallons of just the octane, not the number of gallons of all of this mixture, but just the octane, we would take 0.91 times Y to give us the total gallons of just octane. Remember, it's 91% octane and 9% something else altogether. So if we have a mixture of X gallons of this and Y gallons of that, that's going to be a total of 0.84 times X for the number of gallons of octane in this part of it, and 0.91 times Y for the number of gallons of octane in just this part of it. So our mixture is going to have this much octane plus that much octane, and that's going to give us the number of gallons of octane. So just the number of gallons of octane. I'll just let it be a phrase for now. Number of gallons of octane in the entire thing. So that's the expression that they want in Part A. Part B says, evaluate the expression if 1,000 gallons of 84 octane gas, so now we have 1,000 here instead of X, and if 2,000 gallons of the 91 octane gas are mixed together. So how much octane would there actually be? So in this case, you do 0.84 times 1,000, and you'd add that to 0.91 times 2,000. 0.84 times 1,000, well, when you multiply by 1,000, you move that decimal place 3 times, so it would be 840 gallons of octane in this part of it. Okay? And if we multiply 0.91 times 2,000, pull out your calculator if you need to, that's fine. But you're going to have, and you're going to move the decimal place 3 times. So in this 2,000 gallons, 1,820 gallons are going to be just octane. The rest of those 2,000 gallons, that 180 gallons, is going to be something else. And we don't care about that something else. So that's going to give us a total of, see if I can do this in my head, 2,660 gallons of octane. All right? That's a total of 2,660 gallons of octane. Remember, though, that was 1,000 gallons total of this one and 2,000 gallons of that one. What's the total volume of gasoline that was used here? So the total volume of the stuff that's more than just the octane would be 1,000 plus 2,000, which is 3,000. So out of the 3,000 gallons of gasoline, 2,660 gallons were octane. So in order to do part C, which is what will the octane number be, we would have to divide 2,660 divided by 3,000 to figure out the octane number. Now you can do that in your head, or you can use a calculator. I'm using a calculator right now to do that little bit of arithmetic. And I find out that that is 88.67% octane. They don't tell us exactly what to do with the leftover bit, so I'm going to round it up, and I'm going to say that that octane number would be an 89 octane gasoline. And we have 3,000 gallons of 89 octane gasoline. Okay? Part D, the final part of this problem says, if the wholesaler receives an order for 15,000 gallons of 89.7, well, I guess you could say that this is 89.7 octane gas, how much of each should be mixed to fill the order? So we know we need 89.7 gas, but we don't want 3,000 gallons. No. We have an order for 15,000 gallons. So we need to do 5 times this, right? How much of each kind should be mixed? Well, if we need 5 times as much, we need to multiply this one times 5, and we need to multiply that one times 5. So that would give us a total of 5,000 gallons of the 84 octane and 10,000 gallons of the 91 octane to get a total of 15,000 gallons of the 89.7 octane gas. How did I figure that out again? I knew that 89.7 octane was found by taking 1,000 gallons of this one and 2,000 gallons of that one. So if I needed not 3,000 but 15,000 gallons total, I'm going to have to multiply by 5 each one of those, because 3,000 times 5 will give me 15,000. So I multiply the 84 octane by 5, I multiply the 91 octane volume by 5, and that gives me 5,000 gallons of the 84 octane, 10,000 gallons of the 91 octane to get my final answer. Okay? Sometimes that can be a little bit tricky on these mixture problems, but really there are 2 different things to think about. First of all is to get the number, to figure out the number of gallons of pure substance. Each one of these was not pure. Only 84% of this one was octane. So 0.84x would give me the number of number of gallons of just pure octane. 91 octane means that it's 91% octane. So 0.91 times the number of gallons of that will give me the total number of gallons of pure octane. Okay? But I also needed to know the total amount of each one of these. If I wanted a total of 2,660 gallons, I would have to know that some of those gallons came from the 84 octane and some of those gallons came from the 91 octane. All right? So you can go ahead and figure out the total volume and the volume of just the pure stuff. And then to figure out the percentage that you have at the end, you would divide the volume of the pure stuff by the volume of the total amount that you have. Go ahead and try a few other problems and let me know if you have questions. You'll use this technique of setting up a chart like this several times as you work through these as you work through the mixture problems. Especially I want you to try the silver alloy problem, which is problem number 19. Okay? Let me know if you have a question. Have a great night.